Okay, that one. It says work each problem, then write the answers of the ordered pair and follow instructions to the graph. See on the back how there's a pumpkin? It's going to make a graph. Okay, so what is the value at which there is a vertical asymptote of this f of x for number 1? Where do we get vertical asymptotes? In a rational function, when do we see vertical asymptotes? Okay, when it's a non-removable discontinuity that equals 0. Sometimes they're removable and that would be a hole. So we would need to factor this. The numerator can factor and the denominator can factor. Okay, Ethan, how does the numerator factor? What? Yeah, both positive though, right? Okay. Yep. And then the denominator, they're both perfect squares. The square root of x squared is x, square root of 9 is 3, and we have positive and negative, right? So that would add to 0. So x plus 3 cancels, which means that creates a hole at -3. There's a hole when it's removable. The non-removable is your vertical asymptote. So the non-removable would be what? There is a vertical asymptote at x equals 3. Okay, let me get... Why don't you go look at part B? So large. Okay, what are the factors in the numerator, John?
X minus 7,
I agree with those. Okay, Jake, what about the denominator? Yep, I agree with those too. So, where's the hole? X equals positive 3, that removable is a hole at x equals positive 3, but the vertical asymptote, which it wants, is the non-removable at x equals, what makes this 0? X plus 5, so what number for x would make it 0? X equals -5. So it tells you in the directions, part A and part B, create your ordered pair. So the point on the graph would be... Oh, it wants the removable. I didn't read the directions. Yes. Thank you. A hole at x equals 3. So the point you'd be plotting is 3, 3. Okay, because 3 from part A is the x, 3 from part B is the y. Okay, let's move down. I think you can do the other ones. Let's review instantaneous rate of change. For 4, what is the instantaneous rate of change of y equals 3x squared plus 10x when x equals -2? What does instantaneous rate of change mean? Because it's at an instant. 1 point, you're finding the derivative. Okay, so the derivative, and when it's at a certain x, we're going to evaluate. Okay, read what would the derivative y prime equal? Cool. And now it wants us to evaluate when x is negative 2. Okay, so what is the instantaneous rate of change at x equals negative 2? Negative 2. Okay, so for our left eye, the first point has an x-coordinate of negative 2. Find, what does this fraction mean on part B? Second derivative. Okay, now don't let these fractions fool you. If it helps you, you can write the fraction as a multiplier in front, x cubed plus 1/2 x squared plus x. That's y, though. It wants the second derivative. Means you have to take the derivative twice. And each time you take the derivative for polynomials, it decreases in power. So your first derivative should be a quadratic. Your second derivative should be linear. Okay, let's hear y prime. Rebecca, what'd you get for y prime?
X squared.
Good. And y double prime, which is the same thing as saying dy dx squared equals, John? Yep. So we want to evaluate y double prime when x is 1. You just plug in 1, and we get 3, right? So on your picture, that would be the y, okay, to begin drawing the left eye. Number 5, let's do number 5, because part B doesn't say instantaneous rate of change, it says average rate of change, and you have to know the difference. Instantaneous means takes the derivative. Average rate of change has 2 points. Okay, so part A, find dy dx when x equals negative 2. It says find dy dx, you should be thinking take the derivative. When it wants it at a certain x, then you evaluate at that x equals negative 2. Okay, Reed, what did you get for that one? Yeah, the answer when it's evaluated. Negative 3. I agree with that. Okay, for part B, find the average rate of change. It's different than instantaneous rate of change. What does it mean when you're taking the average rate of change? The slope. F of B minus f of A over B minus A. And it gives you B and A. A is negative 1, B is negative 2. So f of B means we're going to plug in negative 2 cubed plus 1 minus everything from f of A. F of A, we're going to plug in negative 1. So negative 1 cubed plus 1. The parentheses on the negative 2 and the negative 1 are important. All over, this is also important, negative 2 minus a negative 1. Be very careful on the signs. Is there any questions how I set this up? This is f of b minus f of a. I put all in parentheses because everything was being subtracted. Divided by b minus a. Simplify that through carefully using please excuse my dear Aunt Sally order of operations. When you think you know the answer to B, put your fingers up in the air. What is the answer to B? Yep, good. What did you get? 7? Because this cancels to 0, and we get negative 8 divided by negative, not negative 8, negative 8 plus 1 divided by negative 1, which is positive 7. Okay. Flip to the back. Ooh, there's some trig functions. Let's review some of those. You want to do the whole thing, and then it draws a nice little picture. 7a is what we're actually going to learn today. So you don't know how to do that. So it's 8a. But we can at least evaluate. Oh no, we can't evaluate because it's hooked to a and a. So 7a and 8a involves implicit differentiation, which we were going to learn today, but we're not doing that. So number 9. What is the slope of a horizontal line? 0. M equals 0. What is the slope of the perpendicular line to that equation? You'd probably want to get into mx plus b form, right, to be able to see the slope. And perpendicular, remember, is opposite reciprocal. Okay, so when you solve this, let's see, we have equals negative x plus 7 divided by a negative 2 divided by a negative 2. So the original slope is 1/2. So the perpendicular, or remember that other word, what's the other word for perpendicular? Normal would be negative 2. So 0, 2. Okay, and then you just plot those in order. Are there any questions you're just dying to get help on the review of any of your formal reviews? You should be reviewing your Chapter 1 review. You should be reviewing your Chapter 2 review. You should be reviewing your Chapter 3 review, which I gave you last time. Would you like study sessions after school on Wednesday? Tuesday, I have 10th graders coming in, but Wednesday, if you're interested in coming to ask questions on anything from chapters 1, 2, and 3. Oh, the test is Wednesday. Ah, that doesn't work. Today after school. You can do today after school. 10th graders come in on Tuesday. Yeah, sorry. Today after school we could do. Any questions on the review I gave you last time, or anything you... Okay. Number 17 off of the Chapter 3 review. You can finish that after the test. Okay, 17. QR equals R cubed cosine R. So really these should be saying find DDR instead of DDX. Okay, well we have to realize what rule is this asking for to find the derivative. Is it a function stuffed in a function? It's the product rule. Firsty last plus lasty first. So dq dr, the derivative of q with respect to r, is first, r cubed, d last. What's the derivative of cosine r? Negative sine r. First d last plus last, d first, the derivative of the first. 3r squared. And you could probably leave it that way. Sometimes we like to simplify it a little bit by moving that 3r squared in front. Or you can pull out the common factor. You just take the derivative of that guy. Which means you have to do product rule twice. You have to do product rule here and product rule here when you take the second derivative. Okay? Cool. If you want to come ask questions after school, please come in.
Don't want to fall on my test.